For video 3 of solving radical equations, we're going to take a moment to practice using our graphing calculator to check our work. So the example that we're going to look at is going to be the square root of x minus 4 plus the square root of x plus 4 is equal to 4. Our approach when using the graphing calculator is going to look very similar to the approaches that we had used in previous videos with regards to solving equations. So what we're going to go ahead and do is we'll go into the y equals screen next, and the left side of the equation will get one line, and the right side of the equation will get the other. So we'll go into y equals, and again, to enter this in, we're going to do second and x squared to get that square root symbol. Our variable key is located in between the alpha and the stack key. And we're going to do minus 4. And it's very important at this point to use your right arrow key to get out from underneath the root. So then we'll do plus, and again, second x squared key to get the square root symbol. And then we'll do x plus 4. Now I'm going to go ahead and arrow down to the y2 line, and this is where I'm going to put the right side of my equation in. So that's just 4. So just in case you've been playing around with your calculator for a while now, you might need to reset the window for your graph. So before we actually go ahead and graph, we can go into Zoom. And I'm going to actually select option 6, which is Zoom Standard. It's going to give me a nice 10 by 10 coordinate plane. So I could either arrow down to 6 and hit enter, or I could just press 6 on my keypad. And here are two halves of the equation graphed together. And again, what we want to note here is, since we have those two sides of the equation set equal to each other, hence why we're using an equation, our answer is going to lie where these two graphs intersect one another. In order to find out that exact intersection point, instead of trying to maybe eyeball it, which could become problematic, especially if our answer is a fraction or a decimal answer, we're going to go ahead and hit second and trace. And this is going to open up a list of options for us. We're going to want to select option 5 for intersect. So here I'm going to have to do a little bit more arrowing because I want to see that blinking cursor on my first equation, which is what is appearing on our screen right now at the very top. So I'm going to use my right arrow key, and again, I can kind of follow along and see what x value is appearing on the screen. So notice right now I'm just seeing an x value and there is no y value. So essentially we're not even on this graph yet. So I'm going to keep pressing the right arrow key. My numbers are increasing, which is good. It looks like I'm getting closer. And now I'm actually on my graph. So I'm on that first curve, so I'm going to hit enter. And then it immediately jumps to the second curve, and in this case, it already is on the curve. So I think that's pretty close to the intersection line, so I'm not really going to play around with it. You may if you wish. But I'm going to go ahead and hit enter. And now it's asking me, okay, do you want me to guess where that intersection point is? So I'm going to say, yeah. And here is our solution. So if we solved this one by hand, we would find that our solution should be x is equal to 5, since that's the variable that we're trying to solve for. So the next question might come up, well, what happens if I'm working on a problem where there is no solution? What would that look like on my screen? So let's go ahead and investigate that. In order to investigate a situation where there is no solution to an equation, I'm going to borrow one of the you-try problems from the previous video. So the square root of x plus 1 minus the square root of x minus 1 is equal to 2. So again, we already know that there isn't a solution available to this equation. So we really just want to know, what is this going to look like if I try to graph this? So let's go ahead and go back into y equals and enter this in. And I'm just going to go ahead and overwrite things. You can hit clear and start from scratch if you wish. I'm actually just going to move my cursor through here and just do a little bit of editing. So my first radical had an x plus 1 in it. I'm going to arrow out from underneath. I'm now going to change that to a subtraction sign. I'm going to arrow in and change this to a minus 1. And then I'll just arrow down and overwrite this to a 2. Now let's go ahead and hit graph. So there's my first equation, or part of my equation, there's my second half, and notice that they're not touching one another. So we might say, well, maybe it's just off screen. And again, I can kind of tell you that given what we are working with, we probably will not see it touch, but if we want to be certain, you know, because seeing is believing sometimes, what we might want to do is go into zoom, and I'm going to select option 3, which is zoom out. So in other words, it's going to kind of, you're going to step back and try to get a bigger view of the picture. So I'm going to hit option 3, and at this point, it's really just telling you, like, I'm going to step away while focusing on the origin, and I think that that's fine for now. If you wanted to, you could arrow maybe a little bit over to the right, for example. But in order to actually zoom out, now we're going to hit enter. So as you can see, we stepped further out, and I'm still seeing there's a gap here, and actually, if you kind of look at it, it's not getting any smaller. In fact, it looks like it's widening. So in this sense, since there is no intersection, this is why there is no solution. So again, you now have an algebraic approach in order to kind of solve these problems, and now you have a graphical approach using your technology to kind of check your work. I hope this video was helpful. If you do have any questions, please let me know.